Hi everybody, this is the second of 3, possibly 4 videos that will cover section 3 of chapter 3, where we are talking about measures of relative position. Now in our first video, we talked about percentiles. So we don't need to talk about that anymore. I think we beat that horse as far as we can. In this video, we're going to talk about quartiles, interquartile range, and standard scores. Quartiles and interquartile range, they're very closely related. Standard scores are very important because we will be using this throughout the remainder of the course in a variety of ways. Okay, now let's move on to quartiles. Here we go. Now, before we talk about quartiles, let's go back to percentiles just briefly. Now remember, percentiles, you take a data set and you divide all of them into 100 different parts. So each percentile contains 1/100th of the entire data set, which really only makes sense when you have data sets of whose sizes are 100 or bigger. Quartiles, now there's also this thing called dectiles, where you take your entire data set and you break them into disjoint groups of 10. Okay, where each dectile contains 1/10 of the data. Well, quartiles, you guessed it. We take the data sets and we divide them into 4 equal parts. Okay, here's the first quartile between the minimum and Q1. Here is the second this is the second quartile, and Q2 actually happens to be the median. This is the third quartile and the fourth quartile. And so what we have to do to make this division are to compute these 3 values. Now, one of the things I want you to notice here is that at the third quartile, 75% of all the data values are equal to or less than this particular number. What does that tell you? That tells you that the third quartile is also the 75th percentile. Okay? In the second quartile, right here, 50% of all the data values are equal to or less than this number. Okay, I know I don't have equal to in here, and it actually is a minor point here. So this is the 50th percentile. This would be P50. This would also be the median, and that is an important thing to note, that the median is equal to Q2. That's supposed to be Q, by the way. Okay, so whenever you see Q2, you need to think median. And then finally, since at the first quartile, 25% of the data values are less than this particular number, so this is also equal to P25, the 25th percentile. Okay, how do you compute them? It's pretty straightforward. The first thing you want to do is you want to find Q2. How do you find Q2? It's the median. Find the median. Once you find it, call it Q2. And we know how to do that. How do you find the median? 1, you sort the data. And then 2, it's the number in the middle. Okay? Once you've found the median, you want to use the median to divide the data set into an upper half and a lower half. Just think about it. You found the median. Here it is. Okay, so we're going to break the data set into an upper half here. No, I'm sorry. A lower half here and an upper half here. Okay, now, if it turns out that the data set is odd, do not include the median in either half because it skews the result. If the data set is odd and there actually is a number in the middle, don't include that number in either the upper half or the lower half. If the data set is even, then it's not a problem. Okay, once you've done that, then just go ahead, find the median of the lower half. That's Q1. Okay, and then next, find the median of the upper half. That is Q3. That's all there is to it. It is that straightforward. And even if it is that straightforward, it's not a problem. Your calculator can do it for you anyways. Okay, so let's move on to. Oh, I thought we had an example, but no, we have the interquartile range. As I mentioned in section 3.2, there was another measure of dispersion. It was called the IQR. What is the IQR? Basically, the IQR is the range of the middle 50% of all the data values. Now, there's half of the data values that are in the middle or the IQ corresponds to the interquartile range. So that will be the difference between Q3 and Q1. That is what we call the IQR. Okay, so let's go ahead and talk about how to find our 3 quartiles. Okay, so here we are. Here's our data set. Okay, apparently these consist of speeds obtained by the highway patrol over one weekend. This right here is probably me. And we need to find our 3 quartiles. Well, the first thing that we have to do is find Q2. Well, the first thing we have to do is sort this. But hey, I already sorted it for you. You're welcome. Okay, now that we know that it's sorted, we can find Q2. First thing we need to do is count the number of data values we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. An even number of values, because there's going to be 2 numbers in the middle. 1, 2, 3, 4, 5, 6, 7. Okay, that's one number in the middle, and this will be the other number in the middle. How do I know that? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the Q2, or the median, is going to be the average of these 2 values. The average of 70 and 71, 70.5. So Q2 is equal to 70.5. Now that we've done that, we can divide this into an upper half and into a lower half. Okay, so we can look at the lower half and figure out what Q1 is. Notice here we have, and Q1 is going to be the median of the lower half. Here we have 1, 2, 3, 4, 5, 6, 7 data values. This right here is the data value in the middle. So Q1 is going to be equal to 65. Similarly, 78, this number right here, is the number in the middle for the upper half. So Q3 is going to be equal to 78. So there we are. We have our 3 quartile values. As far as the IQR is concerned, remember the interquartile range is going to be the difference between Q3 and Q1. So that will be between 78 minus 65. 65, which will give us 13. So we've talked about percentiles and quartiles, which are comparisons relative to position. The last thing that we want to talk about are z-scores, which are comparisons relative to the mean and standard deviation. Specifically, the z-score tells you how many standard deviations your data value lies from the mean. So if I had a z-score of 1, that would tell you that your value is exactly 1 standard deviation above the mean. If I had a z-score of -2, that would tell you that your value is exactly 2 standard deviations below the mean. Why is this useful? Well, because it provides you a way to normalize and compare data values from different samples or different populations by normalizing out the standard deviation and also normalizing out the mean. How do you do that? It's relatively straightforward. For a population where you know the population mean and the population standard deviation, you take your value, subtract it from the mean, divide the result by the standard deviation. Similarly for for samples, you take your data value, subtract it from the sample mean, divide that by the sample standard deviation. So it is a relatively straightforward endeavor, and we are going to basically demonstrate this using one example. And here it is. We have 2 girls, Jody and Ashley. Jody scored an 87 on her calculus test, and she says that her class had an average or a mean of 80 with a standard deviation of 5. And then Ashley scored an 82 on her calculus test, and she had a mean of 73 and a standard deviation of 6. And the question is, which one really did better on her test compared to the rest of the class? Well, to do that, we need to compute the z-scores. Okay, so let's take a look at Jody. The z-score associated with Jody is going to be equal to her score, 87, minus the class mean, which is 80, divided by the class standard deviation, which is 5. And that is going to give us 7 divided by 5, which if you knock that out in your calculator is 1.4. Okay? What about Ashley? Well, the z-score associated with Ashley is going to be her score, which is 82, minus the mean, which was 70, class average, which was 73, divided by the standard deviation, which was 6. 82 minus 73, that is 9. That's not 9 over 6, 1.5. So the answer to that question would be that Ashley did better. So it is a very simple computation. It is a computation that you will use repeatedly in this course as we move on to normal distributions, to confidence intervals, and into hypothesis testing. And I'm going to close this video with one example which will serve you well in your homework. It gives you the opportunity to demonstrate your understanding of the meaning of the median salary and the 61st percentile, along with mean and standard deviation and z-score. So here's what we have. Let me get my notes. The mean salary at a local industrial plant is $29,600. That is the average, with a standard deviation of 4,400. So we can use that stuff to compute z-scores. The median salary is 25,300, and the 61st percentile is 30,600. I should have said 25,300. Now remember, what does median salary mean? Well, median is the same thing as the 50th percentile, or the same thing as Q2. Q2 will probably not apply here, but the 50th percentile does. All right, now let's look at question A. Based upon the information above, are approximately 61% of the salaries less than or equal to 30,600. Well, 36,600 is the 61st percentile, which means that 61% of the salaries, by definition, are at this value or less. So the answer here would be yes, not no. Okay. Luke has a salary for part B. Luke has a salary of 40,600. How many standard deviations is that above the mean? That's their way of asking, well, what is the z-score associated with Luke? Well, to figure that out, we need to use our z-score formula. That is going to be equal to Luke's salary, 40,600, minus the mean, which is 29,600, divided by the standard deviation, which is 4,400. That is going to be equal to 11,000. Oh, forgot the one there. There we go. Divided by 4,400, which is equal to 2.5. It is 2.5 standard deviations above the mean. Because remember, that's what the z-score tells you. Okay, we have 3 more questions relative to this one. Okay. What is the percentile rank associated with 25,300? I think I actually already answered that question over there. It's the median salary. The percentile rank is 50. So this would be the 50th percentile. So we could either just say P50 or 50th. You actually will see this in Hawks. I think it'll be a yes or no question as far as that's concerned. Okay, based upon the information, what percentage of all the salaries lie between 25,300 and 35,600? Well, remember, 35,600 is the 61st percentile. 61% of the salaries are below this value. This is the median. This is the 50th percentile. I should just go ahead and call that P. So 50% of the salaries are below this. Okay? So the percentage of all the salaries that are between 25,300 and 30,600 is going to be the difference between 61 and 50. 11% of all the salaries lie between 25,300 and 30,600. That's basically P61 minus P50. You have 11% left. Okay, and then finally, suppose Zoe salary has a z-score of 1.7. How much does he earn? Well, remember, z-score is equal to x minus the mean divided by the standard deviation. So here we're going to have 1.7 is equal to x minus 29,600, that quantity divided by 4,400. It's going to require a little bit of algebra here to figure this out. Okay, so what do we want to do? We probably want to get rid of the, probably want to multiply both sides by 4,400. So times 4,400 times 4,400. Oh, forgot the 4 there. There we go. These will cancel. And we will have this equals 7,480 is equal to x minus 29,600. Okay, remember we're trying to solve for x. We want to get x by itself. To do that, we need to get rid of this. To get rid of that, all we need to do is add 29,600 to both sides. Okay, these will cancel. And we will have that x is equal to $37,080. That will be our answer for Zoe. And that is all that I have for this particular video. Went a bit longer than I thought. Sorry about that. Stay tuned for my next collection of videos, which will be a combination of homework and technology. It might be one video, it might be two. I haven't figured that part out yet. But stay tuned and see what I come up with. Until then, this is Bob Boyle, signing off.